What if you could design systems that don't just predict outcomes but actively adapt and improve every piece of new data that they encounter? That's the power of machine learning, creating systems that not only predict but also learn and evolve, becoming smarter over time. Hey everyone, welcome to the Machine Learning Engineer Roadmap for 2026. As technology continues to advance, machine learning has become the backbone of many cutting-edge applications, everything from autonomous vehicles to recommendation systems. But how do you go from a beginner interested in machine learning to someone who can actually build these intelligent systems? That's exactly what we will be covering in today's video. In this video, we'll explore the Machine Learning Engineer Roadmap for 2026, what machine learning really is and why it's shaping industries today, key skills that you'll need to thrive as an ML engineer, the 6-month plan to jumpstart your ML career, along with real-world projects that you will work on to build practical experience, emerging ML trends for 2026 and beyond, career opportunities for ML engineers in 2026. By the end of this video, you'll have a clear roadmap on how to begin your journey as an ML engineer and understand the skills and projects that will help you stand out in this field. Before we dive in, let me quickly mention something that can help you accelerate. Before we continue, here's a quick quiz question to test your ML knowledge. What is the core skill needed to become a machine learning engineer? Is it A, graphic design, B, Python programming, C, marketing, or D, content writing? You can drop your answer in the comments below. We shall now begin with what has changed in machine learning by 2026. So you might be wondering, what's changed in machine learning and why is it the best time to get into it now? Well, let's go back a few years. In the past, machine learning was more about building models based on historical data. It was about training algorithms to predict specific outcomes like classifying emails, spam or not spam, predicting house prices based on past data. But fast forward to 2026 and the landscape has changed dramatically. Today, machine learning isn't just about making predictions, it's about building systems that can learn, adapt, and improve over time. We're no longer creating algorithms to just run experiments offline. Now, machine learning systems are integrated into real-world operations and are capable of making decisions that impact the business immediately. Here's an example to make it clearer. In the past, an e-commerce website might use machine learning to predict what products a customer might want based on their past purchases. Now, the systems can constantly learn from new customer data, continuously refining those predictions in real time as customers' preferences are changing. The world of machine learning has evolved from theory to practice, and this has created a huge demand for machine learning engineers who can build scalable systems and make them work in real-world environments. The impact of machine learning is now directly tied to business outcomes, and machine learning engineers are at the center of that transformation. You might be thinking, okay, I get it, machine learning is impactful, but what exactly does a machine learning engineer do compared to other roles in tech? That's a great question. In the world of machine learning, you'll hear about a few key roles such as data scientist, machine learning, and AI engineer. Let's break them down so you know exactly where you fit in. Data scientists are like the detectives of data. They spend their time analyzing large data sets, finding trends, and trying to extract meaningful insights. They build models, but their main focus is usually on data exploration and experimenting with various algorithms. They don't typically focus on deploying those models into production environments. Machine learning engineers, on the other hand, these are architects. They take the models built by data scientists and build scalable, deployable systems. They work on creating solutions that will not only work in the short term, but can also scale to handle real-world data in massive volumes. The machine learning engineer is responsible for ensuring that machine learning systems are integrated into businesses that can work seamlessly with existing technologies. AI engineers focus more on the application side of things. They build AI-powered products like chatbots, voice assistants, and real-time systems. While their work often overlaps with ML engineers, they are typically more focused on the user-facing product and how machine learning fits into it. As an ML engineer, your primary focus is to take models and turn them into actionable solutions that are deployed in real-world systems. We shall now move on to why 2026 is the right time to enter machine learning. Now that you know the role of an ML engineer, let's talk about why 2026 is the perfect time for you to jump into the field. You've probably heard that machine learning is a hot topic, but what does that mean for you as someone starting out in this field? So I'll help you break that down for you. First, the demand for ML engineers has skyrocketed. The world is full of problems that need solving, and machine learning has proven to be one of the most effective tools to solve them. From predicting customer preferences to automating critical business functions, machine learning is changing how businesses operate. Secondly, the tools used to build machine learning systems are more accessible than ever before. In the past, machine learning was viewed as something experimental, something that required a lot of effort just to set up. But today, machine learning platforms and frameworks such as TensorFlow, PyTorch, and scikit-learn have matured significantly. These tools make it easier to build and deploy models that can scale to handle real-world data. We shall now move on to why is this the right time for you to get started out as a machine learning engineer. So how do you get started? The first step is to build a strong foundation. You might be excited to start building models and diving into algorithms, but before that, you need to understand the core concepts that drive all the machine learning systems. These include mathematics, programming, and data handling. You don't need to be an expert in all of these areas, but you do need to understand the basics. Think of these as building blocks of everything that you will need to learn machine learning. Let's start with mathematics. You don't need to be a math genius, but you do need to understand the basics. There are three main areas of math that will help you get started out as an ML engineer, and those are linear algebra. This is the study of vectors and matrices which are used to manipulate and process data in machine learning models. If you've heard terms like feature vectors or matrix operations, that's linear algebra at play. This is the core of how machine learning algorithms operate. This is the math behind optimizing models. You'll use calculus to adjust the parameters of machine learning models and minimize the error between predicted and the actual values. Specifically, derivatives are used to find the best way to fit a model into the data. Statistics. Machine learning is all about working with uncertainty, and statistics will help you make sense of it. Whether you're dealing with probability distributions or hypothesis testing, statistics can help you understand patterns in data and make decisions with uncertain information. These mathematical concepts will help you build a more accurate model and optimize it effectively. Let's move on to programming stack. If you're new to programming, don't worry. Python is the language that you will want to learn. It's simple to get started with and has a huge ecosystem of libraries especially designed for machine learning. The key libraries that you will need to master include NumPy. This library is used to handle large arrays of matrices and data, which is the backbone of most machine learning algorithms. If you plan on working with large data sets, you'll be using NumPy a lot. Pandas. This library is great for data manipulation and analysis. You'll use pandas to clean, organize, and transform data, making it ready for machine learning models. Scikit-learn. This library provides simple, easy-to-use tools for building machine learning models. It covers everything from data pre-processing models like regression and classification. Once you're comfortable with these tools, you'll be able to start building machine learning models and working with real-world data. Next up is SQL, which stands for Structured Query Language. As an ML engineer, you will be working on lots of data, and SQL will help you query databases to retrieve information that you need. You'll use SQL to extract data, filter it, and join tables together, making sure that you have the right data to your models. Once you have your data, the next step is data wrangling. Data wrangling is a huge part of your job, and if you master it, it'll save you a lot of time and frustration while building models. We shall now move on to types of machine learning. Let's talk about the different types of machine learning. There are three main categories, which are supervised learning, unsupervised learning, and reinforcement learning. Speaking of supervised learning, this is when you have labeled data. You train your model on data where the answers are already known. The goal is for the model to learn the relationship between inputs and outputs so it can predict the future outcomes. Unsupervised learning. In this case, the model works with unlabeled data and it tries to find hidden patterns and groupings in the data. This is useful for tasks like clustering or anomaly detection. Reinforcement learning. This type of learning involves training an agent to make decisions by interacting with its environment and receiving rewards or penalties based on its actions. This is often used in game AI or robotics. We shall now move on to feature engineering and evaluation. After cleaning your data, the next step is feature engineering. This is the process of transforming raw data into meaningful features that help your model make better predictions. Once you've engineered your features, it's time to evaluate the model. You'll use metrics like accuracy, precision, and recall to see how well your model is performing. Proper evaluation ensures that your model is ready for real-world applications and that it can handle data in production. We shall now move on to the 6-month learning plan in order to become an ML engineer in 2026. So how do you actually get started? Here's your 6-month learning plan to guide your journey. Firstly, focus on learning Python, mathematics, and SQL. Dive into machine learning algorithms and hands-on projects. Then, learn deep learning and work with frameworks like TensorFlow or PyTorch. By the 6th month, you can work on a capstone project that covers the full pipeline from data collection to deployment. We shall now speak about the ML engineer tool stack. So let's talk about the tools that you will need as a machine learning engineer. You must be wondering, what tools should I be learning to become a successful ML engineer in 2026? So let's simplify this. Git and GitHub are the first things on your list. At first glance, version control might seem like something that only coders need to worry about. However, it can be really crucial. Why? Because version control allows you to track every change that you make to your code, collaborate with teams, and roll back changes if something goes wrong. Imagine you're working on a huge project and you mess something up. Without version control, you could lose hours of work. But with Git and GitHub, you could go back and fix to any point and time. You might be thinking, okay, I get that Git is useful, but what about the tools that can actually help me build and deploy machine learning models? Now that's a great question. So let's talk about the cloud platforms like AWS, Google Cloud, and Azure. In the past, machine learning models were often built and tested upon local machines, but we quickly realized that it wasn't scalable. These cloud platforms give you the ability to handle large data sets, run models on high-powered servers, and scale them as your projects grow. Instead of relying on your personal laptop to do all of the heavy lifting, you can leverage the cloud to train models much faster and handle massive data sets without worrying about memory limitations. We shall now move on to the next topic, which is on MLOps lifecycle. You have now got all of your tools in place. But how do you go from all of these tools coming together in the MLOps lifecycle? So you must be wondering, what does all of the MLOps lifecycle tools even look like? And how do I manage the process from starting to finish? Well, here's the thing. MLOps is like a well-oiled machine. It involves a series of stages that ensure that your models remain reliable, scalable, and adaptable to new data over time. Think of it like a car assembly line. First, you train the car, and then you deploy it into the real world. After that, you need to monitor it and see if it runs smoothly. If it breaks down, you will have to retrain it. Let's break it down into key steps. Training your model. This is where you create the model using your training data. This is a very experimental phase where you try different algorithms, tweak parameters, and optimize the model for better performance. Deploying it to production. Now that your model is ready, it's time to put it into action. This means making the model available to users or clients. Whether it's in a mobile app or a web service, deployment is where the magic happens. Monitoring performance. Once your model is live, you can't just forget about it. It's like checking the car's tire pressure after it's been on the road for a while. You need to continuously track how well your model is doing. If it starts to slip or underperform, it's time for tweaks and adjustments. Lastly, we have retraining. Over time, your model may need to be retrained with new data to stay accurate. This is especially true in industries where the environment is constantly changing, like e-commerce or finance. Retraining ensures that the model stays relevant and continues to provide value. You may be wondering that this sounds like a lot of work. And that's true. That's where MLOps tools like MLflow help you streamline this process. By automating and managing this lifecycle, you can spend less time dealing with the backend and more time focusing on building innovative solutions. We shall now move on to experiment tracking. As you dive deeper into machine learning, you'll quickly realize how important it is to track your experiments. At first, this might seem a little overwhelming. You might be thinking, I can't just run a model and hope for the best, right? But trust me, tracking your experiments is one of the best habits that you can develop early on. Think of it like logging your workout progress. Even if you don't track the results, how will you know whether you're improving or not? The same goes for machine learning. By using experiment tracking tools, flow, and weights and biases, you can keep a detailed record of every model and every hyperparameter and every evaluation metric. Now imagine you're building a recommendation system for an online store. You try different adjustments, algorithms, and get different results. With experiment tracking, you can easily compare which configurations work best. And learn from the past mistakes. You'll always know which experiment gives you the best results and which needs tweaking. Tracking experiments also helps in collaboration. If you're working with a team, being able to see everyone's experiments in one place makes it easier to understand their approach and build on each other's work. We shall now move on to projects and portfolio. Now that you've got your tools and workflow in place, it's time to focus on building a strong portfolio. You might be thinking, how do I make my portfolio stand out to potential employees? That's a great question. The answer is simple: real-world projects. Think about it. Employers want to see what you can do in practice. They don't just want to see theoretical knowledge, they want to see that you can solve problems and build working systems that can make a difference. So for that reason, we have mini project examples. At this point, you're probably itching to start building something yourself. Well, hands-on projects are the best way to solidify what you've already learned. For example, you could create a customer churn prediction model or a fraud detection system. These are practical, real-world projects that demonstrate your ability to build solutions from start to finish. Make sure you document your projects clearly on GitHub and always include a detailed explanation of your approach, challenges, and results. Remember, the goal is to show that you understand the problem and build a working solution. We'll now move on to Kaggle and open-source. As you continue to build your portfolio, I highly recommend diving into Kaggle competitions and contributing to open source projects. Kaggle is an amazing platform where you can work on real-world datasets and solve problems that companies and research institutions are facing. Not only will you improve your skills, but you'll also have the opportunity to see how top data scientists and machine learning engineers approach similar problems. Contributing to open source projects is another excellent way to showcase your skills. It shows that you can work well with others, understanding existing systems, and contribute to the community. Plus, it's a great way to gain visibility and make connections with other engineers. We shall now speak about the resumes which work for you. Speaking about your resume, when it comes to landing a job as a machine learning engineer, your resume needs to be focused on real-world projects and practical experience. So be sure to highlight the projects that you've worked on, the tools you've used, and most importantly, the impact that your work has had. If you build a recommendation engine that boosted product sales by 20%, make sure that you include that. Employers want to see how your work contributes to solving real business problems. Don't forget to include links to Kaggle profile or any other open source contributions that you've made. Employers love seeing code, and showing them your projects is the best way to stand out. We shall now speak about what interviewers test in 2026. By now, you must be wondering, what do employers actually look for in an ML engineer? So in 2026, interviews are not just about technical knowledge. Employers just want to see how well you can communicate your thought process and real-world problems. You'll likely face practical tests that challenge you to build a model or analyze data in real time. You'll also be tested on how well you explain your approach and justify the decisions that you made during the project. Prepare to discuss things like why you choose a specific algorithm for a problem, or how you handle issues like data imbalance or overfitting, along with what metrics you use to evaluate your model's performance. Being able to communicate clearly your process and how you arrive at your solution is a skill that will set you apart from other candidates. We shall now speak about the ML trends that you will need to follow. Machine learning is evolving fast, and staying up to date is key to remaining relevant in this field. So here are a few trends to keep an eye on in 2026. Generative models. These models can generate new data based on patterns they learn, and they're used for things like text generation, image creation, and even music composition. AutoML. Automated machine learning tools are making it easier for non-experts to build machine learning models. As a result, more people will be able to contribute to this field without needing to become experts. Privacy-first models. As privacy concerns grow, machine learning models are being designed to work securely and ethically, and these don't compromise on user privacy. Staying on top of these trends will help you remain competitive and innovative in the ever-evolving field of machine learning. So, in conclusion, I will say consistency is key in machine learning. You don't need to know everything right away, but you must stay committed to learning and building. Start small, keep experimenting, and keep improving. The road to become a machine learning engineer may seem long, but with the right tools and mindset, you can get there. Thank you for watching, and I'll see you in the next one. Thanks for watching the Machine Learning Engineer Roadmap for 2026. We hope that this video gave you a clear path to becoming a successful ML engineer. Ready to take the next step? Explore the Simplilearn's professional certificate in AI and machine learning in partnership with Purdue University. Gain hands-on experience and industry-recognized credentials to boost your career. If you found this video helpful, like, subscribe, and drop any questions in the comments. We'd love to hear your thoughts. See you in the next one.